Now for part 2 of the lab, we will consider network measures. We've constructed the adjacency matrix. We can now use this adjacency matrix to perform operations in MATLAB. And we've discussed 4 operations in class for measures that we'd like to compute. We want to know the number of edges in the network, the degree, the path length between nodes, and the clustering coefficient of the nodes. So let's do that now. And we'll start in part 2a by counting up the number of edges in a network. Now the simplest way to do this, at least for the 5-node network we've drawn here on the left, is to count the number of edges by hand. And we could do that in this case for this simple network. And if we count up, we see there are 1, 2, 3, 4 edges in this network. So that's not so bad, and it works fine for small networks. But what if we have 200 nodes? We would not want to count the number of edges by hand. So there's a better way to do this. We can use MATLAB to count up the number of edges, and we'll do that by looking at our adjacency matrix A. So if we look at our adjacency matrix A, here it is, I plotted out at the command line, we'd like to count up the number of edges. And we might think about how to do that. How would we add up all of these edges? Well, our intuition might be we'd like to add up these ones. So if we add up these 4 ones, we'll get the value 4, and that corresponds to the 4 edges we see in the network. We have to be a little bit careful. Maybe we could try to add the first row in this particular case, but in general that won't work. And we might try to add up all the values in A. So that's one thing we might try, but what happens if we do that? If we add up all the ones that we see in A, we double count the edges. So we get 1 for an edge between node 1 and node 2, and we get a second one for an edge between node 2 and node 1. So if we add up all of these ones, we get 1, 2, 3, 4, 5, 6, 7, 8. We get double the number of edges, and it's because we're double counting. So if we go back to our picture, and if we simply add up all the values in A, we're counting the edge from 1 to 2, and also the edge from 2 to 1. So we double count. But that's okay. If we know we're double counting, we can account for that. And the way we can do that is dividing our result by 2. So again, an intuition we might have is to sum up all of the values in A. This is not the only way to do this, but it's the way I will try right now. So what we'd like to do is we'd like to sum up A. We'd like to sum up the values of A, and we'd actually like to sum the entire matrix, the entire 2-dimensional matrix. So we want to call the sum command and execute it along the first dimension of A, and then sum that thing up again. So we want to sum it twice and also add up along the second dimension. And we might think about what answer do we expect. If we sum up all the values along the first and second dimension of A, what do we get? We get the value 8. Now why do we get the value 8? Well, that corresponds to the 8 ones that we observe here. And again, we said that we've double counted. We count each edge twice. So instead of having, I'm going to hit up arrow here, we're going to sum up A along the first and second dimension, and then we're going to divide by 2. And that should give us the number of edges in the network. We want to sum up A along the first and second dimension, so we're going to sum up all values in our adjacency matrix. That gets us all the ones, but it double counts the edges. So we divide by 2 to get, in this case, 4, the number of edges in the network.